Be dealing with experimental probability, and experimental probability is probability based on experiments or observations. And you've done this before, flipping a coin, rolling dice a bunch of times, and then saying, wow, I've gotten a lot of heads or a lot of number sixes or whatever. And that would be experimental probability if you predicted it based on that. So what you do is by doing the same activity a bunch of times and then, like I said, basing a prediction on this. So if you have an example here, number cube data, if we had this, then the outcome for number 1, 2, 3, 4, 5, 6, then you would guess, according to this, that you'd most likely get a 2 next. If we wanted to figure it out, all we'd do is we add them all up together again, and what we'd end up getting is, when we did that was, well, there's 7 here. Let's see, we got 7, 12, that's 19, 29, 38, 44, 48. I believe that's right. And then if you add those all up together, what you're going to end up with is that the probability of getting a 1, the experimental probability would be 7 out of 48. And 2 would be 12 out of 48 for getting 2, and so on. So it would be only a 4 out of 48 of getting 6. So you get the idea with that. And here, if you were to go ahead and look at the probability, there's experimental and theoretical. Theoretical probability is that for each of these things, it would be actually, you'd be likely to get a 25% chance of each of them, so 1/4 probability. But if you actually spin it, it's not always going to end up that way. But if you do it more and more, if you were to do 1,000 spins, here they only did 100 spins. If you did 1,000 spins, you get more and more likely to get to the close to the theoretical probability. It'll still be off by a little bit probably, but same here. If you were to roll these dice like 1,000 times, you'd end up with a lot more equal divisions. It would be basically 1,000 divided by 6 almost would be for each of these here. It wouldn't be as random. And just as an example here, this is something I did with number cubes, just rolling these 2 dice here. And you know that you can, there's actually 36 total possibilities. 36 possibilities when you roll dice. And that's the reason why here 7 is the most likely of that. If you were to roll them, then you'd have a chance of 6 out of 36 in terms of the real probability, the theoretical probability. But here we got 7 out of 36. We got 7 out of 36 for 6s, and we end up with 1 out of 36 for 12, 1 out of 36 for 2, and no 3s. So this is not the way it should work. You should actually end up with 2 out of 36 if you're going by theoretical probability for 3, but instead you ended up with 0. So that's the difference between probability, experimental probability, and theoretical probability. Theoretical probability is not as nice and neat, but it is important because sometimes you see how a pattern develops that can be helpful if you can't figure out how it actually works using theoretical implements. So that's it.